Hey guys, it's Rishi once again, and today we're back with the cosine rule. And in this video, we'll learn about the cosine rule, including how to use the cosine rule to find missing sides and angles in right-angled triangles, and when to use it instead of getting mixed up with the sine rule, Pythagoras theorem, or SOHCAHTOA. So, what is the cosine rule? Now, the cosine rule is a formula in which we use to calculate missing sides of a triangle or to find a missing angle. Now, to do this, we need to know two arrangements of the formula and what each variable represents. So let's take a look at this triangle here. And this triangle has exactly the same setup as the sine rule, with the sides represented by lowercase letters and the opposite angles represented by the same capitalized letters. For example, side B is opposite the angle at B. And so this is the cosine rule, where we have a squared equals b squared plus c squared minus 2bc cos a. So remember here, this particular rule is used to find a missing side. However, this can also be rearranged to find a missing angle, where you would then have cos A equals b squared plus c squared minus a squared over 2bc. And this there would be for an angle. So I hope that was clear. Now let's go ahead and give you an example of how you can use the cosine rule in question number 1. So the first thing we need to do is label each angle. So we'll go ahead and label this. So we'll go ahead and label each angle as A, B, and C. And then we'll label our sides as the lowercase letters. Now, in order to use the cosine rule, we need to consider the angle that lies between the two known sides. So with this question, we'll be working with angle A, which is 100 degrees. We then have our B value and our C value. And because we are trying to work out the side of a shape, we are going to go ahead and use our formula of a squared equals b squared plus c squared minus 2bc cos a. So before I move on, we have step 1, which is to label our sides, step 2 to state the cosine rule, and then part 3 is to substitute and solve the equation. So let's now go ahead and substitute our values into this formula and solve the equation. So we'll take a squared as our x squared. I'll have 13 squared plus 10 squared minus 2 times 13 times 10 cos 100. Now, if you put this into the calculator, just as I've written it, you should get x squared equals 314.1485. So now we need to get the value of x. Let's root our answer. So x should equal 17.7 to 1 decimal place, just as the question required. And that is our answer, 17.7. So once again, let's take a look at what we've done here. Well, we've started off by labeling each angle and each side. We've then gone ahead and stated the cosine rule before finally substituting the given values into the formula to find the missing side. So I hope that question was clear. Please familiarize yourself with the formula so you know which one to use for the side and which one to use for the angle. Let's now move on to question number 2. So again, we now need to calculate the length of BC. So now I'm going to go ahead and label my sides as my angles have already been labeled. So we'll have opposite A, opposite B, and opposite C. That being said, that's your step 1 done. Step 2 will be to select your formula. So again, we'll have a squared equals b squared plus c squared minus 2bc cos a. And then step 3 is to go ahead and substitute and calculate our value. So we'll then have a squared equals 7 squared plus 5 squared minus 2 times 7 times 5 cos 42. And when we put that into the calculator, we should receive 21.97986. And then again, we need to go ahead and square root our answer. So A then gives us 4.69. And there we are. And that is again to 3 significant figures. So 4.69. Marvelous. So again, just to reiterate, step 1, label your sides. Step 2, pick your formula. And step 3, substitute and calculate the answer. Amazing work. Let's now dive into question number 3. So for question 3, we've been told to calculate the length once more. So once again, let's go ahead and label our sides, select our formula, and go from there. So we now need to calculate AB. And again, I understand AB is seen as your C. And let this not distract you. So let's write out A squared equals 15 squared plus 12 squared, which acts as your B and your C, minus 2BC. And then we have our cos 20 degrees. And if you put that in the calculator, we should get 30.7106. And then if we square root our answer, we should then get 5.5 to 1 decimal place. And that is our answer, 5.5. Okay, now let's go ahead and give you a chance to work out this specific question. Pause the video, attempt the question, and then press play when you're ready to go through it. Okay, wonderful. So let's go through this and let's write out our step 1, which is to label our sides. Step 2, which is our formula. And step 3, to go ahead and substitute and calculate our answer. So we start off with labeling our sides. We've got A, B, and C. We then go ahead and get our formula, which is going to be A squared equals B squared plus C squared minus 2BC cos A. And then step 3, which is to substitute all of the values in. So then we'll have A squared equals 5.3 squared plus 6.2 squared minus 2BC cos 43. And now once we've done that, we should get A squared as 18.4654. And one thing to note, I understand that this is also seen as X meters or labeled as your C. No matter what happens, you can label this as A or X or C. It doesn't make any difference as long as you are comfortable with the formula. And then moving forward, we can have A equals square root of your answer, which then means it's 4.3 to 3 significant figures. And we have 4.30. Amazing work. Alrighty, let's go for question 5. But this time we've been given an angle to calculate. So again, if I label this, we'll have A, B, and C, and then I'll have my lowercase letters. So instantly I've gone ahead and done step 1 already. And now we need to go for step 2 and for step 3. So because we're working with an angle, we need to rearrange our formula. And that's going to be cos A equals B squared plus C squared minus A squared over 2BC. And again, now that we've done that, let's go ahead and substitute and calculate this out. So we'll have 15 squared plus 16 squared minus 20 squared over 2 times 15 times 16. And remember that is equal to cos A. So now we know that cos A, or in this case, cos X, will be equal to 27 over 160. And then if we take the cos over, we then need to write the inverse. We then need to write cos inverse, following through with our 27 over 160. and we should be left with 80.3, again to 3 significant figures. So I hope you can see how we've gone ahead and attempted this question. Number 1, labeling our sides. Number 2, selecting the correct formula. And number 3, substituting and solving the equation. You guys have come really, really far. So keep up the great work. We're almost at the end of the video now. Marvelous. Let's go for question 6. And once again, we're faced with a similar question with our angles. So again, I'll go ahead and label my sides. I'll then go ahead and do step 2, 3 in one go. So I've got my formula, cos x. I'll substitute it right away. So 5 squared plus 9 squared minus 10 squared over 2 times 5 times 9. That then would give me cos x being 1 over 15. But then I need to take the inverse of that, which is cos to the power of minus 1, 1 over 15. And that there gives me 86 degrees to the nearest degree. And there we are. So again, I've now embedded step 2 and 3 together by selecting my formula and substituting it. And that's your 3 marks in the bag. Marvelous. Question 7. Again, we're told to work out the value of x, which is our angle. So I'll label this as A, lowercase a, C, largest C, and your B. And there we are. So now we've done that, let's jump into it. Cos x equals 21 squared plus 13 squared minus 24 squared over, and that's 2 times 21 and 13. We then get cos x, which equals 17 over 273. And if we make x the subject, that becomes cos to the power of minus 1. And that's 17 over 273. And that there gives us 86.4 to 1 decimal place. So again, I've labeled the sides. That's my step 1. Step 2/3 is I select my formula and I solve it by substituting the values in, and then we're good to go. Alrighty. Again, don't forget to pause the video at any given time, attempt the question, then press play and for you to see if we've got the same answer. If you have any questions, comments, or feedback, don't forget to comment below, where I will then take on that feedback to improve the videos. Okay, question 8. Again, we're focusing on an angle. So again, I'll label that as my lowercase a, my lowercase b, and lowercase c, because they've given the angles already. I then need to substitute this into the formula. So again, we'll have 5.2 squared plus 7.3 squared minus 6.9 squared over 2 times 5.2 times 7.3. Once I've done that, I then have cos x, which equals 409 over 949. But if I get the cos inverse of this, I'll have x equals cos inverse 409 over 949, which then gives me 64.5 to 3 significant figures. And there we are. Marvelous work. Okay, we're on to our final batch of questions now. I've made this question slightly more interesting because we've got 2 shapes together. So let's take a look. Work out the value of x. So we need to work out this angle. But there's a slight problem here. We need to have at least 2 sides in order to calculate this. So if we label this as A, this becomes our lowercase a. And if this is our B, this becomes our lowercase b. And then if this is our C, that's our lowercase c. Marvelous. So we've labeled all of our sides. We now need to calculate A. So how do we calculate this side here? Well, the first thing I'm going to do is go ahead and use my formula, and that's going to be a squared equals b squared plus c squared minus 2bc cos A, because we are given our angle. I'll then go ahead and substitute this in, which means a squared equals 10 squared plus 13 squared minus 2 times 10 times 13 cos 40. That there gives me 69.828. And if we make A the subject, that will leave me with 8.356341591. And I've put the entire number here now because this is not our final answer, so I'm not rounding at the moment. That being said, we now know that the length of BC is 8.377. And that's where I'm going to dive into my second step, which is trigonometry. So how do I know when to use trigonometry? Well, we have one side, we have an angle that we need to find. We have two sides now, which is 5 centimeters. We have our angle and 8.3. So using this, I'm then going to calculate my angle. So let's take a look. So I can label my sides as adjacent, opposite the angle, as you can see. And then we have our hypotenuse. So the first thing we're working with is O and A. So again, we have So, Ka, and Toa. And we're going to select Toa because we have O and A. So what am I going to do? I'm going to take my tan x, which equals O divided by A. That in this case is my 8.3 divided by 5. I then make my x the subject. So I have tan inverse 8.3 divided by 5. Don't forget to put all of the other digits after the 8.3. And that there would give us x as 59.1 degrees. And that there is our answer. So once again, I hope you can see how I've labeled all of my sides and my angles. I've then gone ahead and selected my formula, which is my cosine rule, to get the third side, which was 8.356, before using trigonometry to calculate the angle. And that is your multi-step problem, which is perhaps around 5 marks. Let's take a look. Yep, 5-mark question, and that's 59.1 degrees. And that's to 1 decimal place. Beautiful. Okay, question 10. So now we need to work out the value of x. So if we're working out the value of x, what do we need to do here? They've given us a surd, which is root 73, and they've given us some algebraic expressions here. So let's go ahead and label our sides first. We've labeled that. We know we're working with the value of x, which means we're looking for a side. So we'll go ahead and use a squared equals b squared plus c squared minus 2bc cos a. We know that our a is seen as 73. So I'm just going to substitute everything in. So that's x plus 2 squared plus 2x minus 3 squared minus 2 times b and 2 times c. And then we'll have our cos 60. Again, I'll perhaps make this slightly longer for everybody to see. So now I've gone ahead and substituted that all in. And then again, if we expand these two brackets, we'll be given x squared plus 2x plus 2x plus 4 plus 4x squared minus 6x minus 6x and plus 9. And then if we expand this region here, that is 2x squared minus 3x plus 4x minus 6. So now by doing that, let's simplify this. So we're left with 73 equals 5x squared minus 8x plus 13 minus 2x squared plus x minus 6. So I hope this is clear as to what I've done so far. I am then going to go ahead and simplify this. So again, collecting like terms, which leaves me with 3x squared minus 9x plus 19. I'll make 0 the subject as we're working with a quadratic equation. And that gives me 3x squared minus 9x minus 54, as that 73 becomes a negative 73. I then need to simplify this equation by dividing everything by 3. So again, I'm left with x squared minus 3x minus 18. And that again equals 0. And then I need to factorize it. And again, I would use my AC method, where I need to find two numbers that multiply to make minus 18 and add to make minus 3. That there would say 0 equals x minus 6 and x plus 3, which means x equals 6 and x equals minus 3. So x cannot equal to minus 3, as the lengths would be negative. Therefore, our answer for x equals 6. And there we are. And that's how you answer a question similar to this. You substitute your values, you expand, simplify, factorize, and then make x the subject. And there we are. Brilliant. And that there brings us to the end of our video. I hope this session was useful, where we went through a range of different questions, focusing primarily on the cosine rule. I hope you now feel comfortable in terms of labeling your sides, finding the correct formula, and then substituting your values to get the answer. You've done amazingly well, and I cannot reiterate how important this is as part of your GCSEs. So keep up the great work. Don't forget to comment and subscribe to our channel for more useful content. I am very open to your feedback. If something isn't working, let me know and we can improve it. With that in mind, keep up the great work, and I'll see you in the next video.